Hi Professor, this is Dan Riseman with the assignment 1.2. For question number 2, I did a homemade model here. This would be an x-axis, this is the y, and this would be the z. I had a problem with the negative y, it kept on breaking, but you would divide the x, y, z space, divides this into 8 regions. If you think about a negative y, there'd be a region like right here. Think about going down here. There'd be something down here, something down here, and something down here. Those are 4. Then you would have 1 here, 5, 6, 7, 8. Now, your question for number 3 was, if we draw something on this xy line, xyz, what is the minimum regions we would pass through? Well, in fact, if we're right on the axes, imagine we're right on the x-axis, we would pass through 0 regions. I initially thought we would be on 2. If we had to do like a vertical line, we'd go through 2. It'd go through the lower and upper. Or if we did a horizontal, it could go through 2. But why not right on the axes? Right on the z, right on the x, or right on the y, you'd pass through 0 regions. The question about the max number of regions, I think it'd be 4 regions. Imagine we're starting down here. You could go way down here, and then you could take it here. You could go and go below this into this region, and then you could go into the region here, which would be here, a 3rd region, and into a 4th region. So I think there would be 4 regions that you could cross a line through. Number 8, which is a hard question, the idea of the possible intersections of 3 distinct planes. There are 6 scenarios, I believe. You could have it, in fact, where they'd be all parallel to each other and they would not intersect at all. You could have where the 3 planes intersect to form a line, where each plane intersects to form a specific line on the other plane. You could have 2 planes are parallel with the 3rd plane intersecting the other 2 planes to form a line in each of them. Or you could have a situation where the 3 planes intersect at a point, where the 2 planes lying in the same plane are intersected by a 3rd plane to form a line. Now, I tried my best to demonstrate this. It's very tricky, and it won't stand out so strong, but you can see in this situation, I have one here where you have each plane intersects to form a specific line on the other plane. It's not perfect, and it's not standing great right now, but you can see that's how it would be. I tried some others as well. You have these 2 cards, and if you intersect, you could form, again, my cards are not acting up and a lot of things have fallen down, but if you did that, you could form the, this guy right here is what I'm trying to do, but it's not sticking together here. A lot of these cards have fallen down while I stepped away, which is unfortunate. But I'll send you the drawings. For number 10 was, a single point on a fixed distance, it does not determine a unique segment in 2 space or 3 space, because in 2 space this would result in a circle, and in 3 space it would result in a sphere. And here's an example. If you had the midpoint, let's say 3, 1, and 2 space, and 2, let's say, were the length of the segment, you would have a circle. And situation here in 3 space, if you have this situation, you would have your midpoint, let's say, is 1, 3, 2. And in the situation, you do it, and the distance of your segment length is a value of 2, and you draw it out, you would get yourself a sphere. So again, both of these do not result in unique segments. Thank you. This was a really good assignment. It made me think a lot, and I hope to speak with you soon. Take care.